GPU, CPU, ASIC, all cloud gaming platforms must perform three functions: game logic, frame rendering, and video encoding, and use some combination of these three integrated circuits to get this done. In his latest article, Jan Ozer explores the most cost-effective hardware combination for performing these functions. Hey, Jan, I have a question for you.
Shoot.
There is a lot of use in your article: GPU, CPU, ASIC-based VPU. How do you mix them all together for the optimal result?
You focus on achieving the highest stream count for any configuration. And that's what you do. It doesn't matter who made the GPUs, who made the CPU, who made the transcoder facility. How many streams can you get from a combination of those integrated circuits?
You spend the whole bunch of paragraphs explaining stream output capacity. Why is understanding the stream output capacity so important?
It's important because it allows you to make sure that you have an apples to apples comparison of the different hardware combinations that I spoke about a moment ago.
What do you measure with these apples?
When you get the stream count, you want to look at three aspects of this hardware combination. You've got this cloud gaming system. It's a very complex system. It does a lot of things, multiple inputs, multiple outputs on a massive scale. But at the central core, like you started off talking about, you've got game logic, frame rendering, and then encoding. And then in order to compare different systems, you've got a CPU-based system that costs $25,000. You've got an ASIC-based system that costs $10,000, which is more efficient. You can only compare the systems effectively if you understand how many streams they output. So, if you understand the stream output, you can look at the costs and say, okay, my cost per stream from a CapEx perspective is going to be X for this system, Y for that system. And that gives you the apples to apples. You can also understand the watts per stream, how much electricity is required for each output stream, because you're going to know the power draw of the hardware combination for each combination that you look like. And obviously power is both an expense, but it's also an environmental concern. And finally, you have to look at the density, because if you can output 200 streams from a 1-2R rack, you're going to save a lot of costs associated with not only storing the servers, but if you can do it in 5 servers as opposed to 20 with another solution, you're maintaining 5 servers as opposed to 20. So you look at 3 things: CapEx, OpEx, and then the OpEx component that relates to the storage and support of those of the servers producing the streams.
So that is all it comes down to? Cost per stream, watts per stream, and density.
That's right. And that's why in the article we have that broken out for the 3 sample systems that we're looking at, but we also have it broken out so that you can read the article, print a table, and then use that table to come up with the GPU, CPU, ASIC combinations for any cloud gaming platform that you look at, and then easily compute the cost per stream, watts per stream, and then the density.
You mentioned 3 different systems in the article. Where do they come from and what are the components?
So the 3 systems come from 3 different places. One is a NETINT reference design that we have working in the lab as a proof of concept. The second is a system that was publicized by a major cloud gaming vendor who shared some of the performance envelope statistics of that system with us. And the third is a Supermicro system that we saw the performance benchmarks displayed at Mobile World Congress.
Now we know how the systems are built, the combination of CPU, GPU, and VPU. So show me the money.
The money is you're always going to get the lowest CapEx, the lowest OpEx, and the highest density if you incorporate an ASIC-based transcoder into your cloud gaming system.
Wait a second. Let me comprehend this with my little brain. So you are saying that NETINT is the most affordable from the initial investment point of view. NETINT is the most power efficient. NETINT is able to provide the highest output. NETINT is the cheapest from the cost per stream perspective. And this system is not just on paper. It's tested, existing, and available for immediate implementation. Am I missing something?
Nope, that about sums it up.
Did you tell anybody else about this?
We'll be talking about it at NAB.